Here we go. 7 for our last section in chapter 7. All right, we have regular polygons is what we close up with. What does the word regular mean in this case? Well, if we zoom in on this picture, hopefully you see what regular polygons means. It means that they have to be equilateral and equiangular. So all the sides have to be the same length, and all the angles have to be congruent. All right, that's behind the word regular, which to me would make it special, not regular, if you know what I mean. All right, how do I find each interior angle? And I should have the word, that little M here in front of that. Measurement. How do I measure each interior angle? Well, we're going to take the sum of the angle measurements. That would be n minus 2 times 180. And I'm going to divide it then by however many angles I have, which is exactly the same as the number of sides I have. We'll do an example using that in just a moment. The other rule that we have to remember is that if you're working with an exterior angle, you would take the sum divided by n. Again, as we look at these two formulas, hopefully you see that the exterior angle, it's much easier to find. So I'm going to zoom into a diagram here, the hexagon. If I'm working with the hexagon and it asks me to find this, this is easier to find. Just remember, you're finding the supplementary angle to what you're looking for. All right? So we got to subtract from 180 when we do this technique. But if the option is to me, I would rather choose this than this. So here's a problem. It says find the measure in angle 1 in the figure below. We see that this is the exterior angle. Okay? Is this regular? They didn't tell us. If we didn't know that, we wouldn't be able to proceed. So we're going to assume this is a regular pentagon. A regular pentagon has 5 sides, as you can see. So I'm going to take the exterior angle sum divided by 5. And that will give me, I think, 72 angles, 72 degrees, 72 angles. All right, so this angle measurement here is 72. All right, hopefully that makes sense. This problem, we didn't have to find the interior. We could have, but it wasn't required. How many degrees in each exterior angle of an equiangular heptagon? So a heptagon has 7 sides. Again, some books will call it a septagon, other books will call it a heptagon. Kind of depends whether you're using Latin or Greek. Anyways, anywho, we know that we got n equals 7. So if I take my exterior angle sum, again, we're looking for the exterior, excuse me, big yawn. So I take each angle will be 360 divided by 7. I think I'm going to get 51 3/7 of a degree. I think I did that right. All right. Here, slightly different. It says the exterior angle is 18 degrees. How many sides do I have? So this is asking me to do it slightly different. I know that there's 360. I know that when I divide by 18, I get n. So can I solve this? Well, multiply by n. So 360 equals 18 times n. Now divide by 18, as you would suspect, and you'll get n equals 20. So the exterior angle of a 20gon. I was trying to think of the name. What is a 20gon? dodecagon, could be. I don't think it's duo. Duo is 12, but all right. If each angle in a polygon is 108, how many sides does it have? So let's go, this is the inside, this is the interior. It should say that here, if each interior angle is 108. Okay, why wouldn't it be, well, I think you might suspect, oh, it could be an exterior angle too. All right, interior angle. So 108 has to equal that mess, n minus 2 times 180 divided by n. So multiplying both sides by n, we get 108 n equals n minus 2 times 180. Distributing that, we get 180n minus 360. Now subtract the 180n from both sides. And we end up with 72n is equal to negative 360. I'm going to divide by 72. And I think get n equals 5. Therefore, it looks like we have a pentagon. Okay? N equals 5, I've got a pentagon. I think it said how many sides, so 5 would be your answer. All right, finally, last problem. It says, given a stop sign, is that triangle scalene, isosceles, or equilateral? So how do the sides compare? Well, we can see here that I have a pentagon, trapezoid here. This is an isosceles trapezoid. And this trapezoid here would be identical to that. So by CP/CTC, I think these two sides would be congruent. Yeah? So this looks like it is going to be an isosceles triangle. Why? Because I know that NT is congruent to NE. All right, well, that's your